Hi everyone, my name is Karolina. I'm an account manager at Nuaware. As a company, we specialize in helping organizations choose the tools, partners, and skill sets needed for successful adoption of enterprise-grade technology. The topic for today's presentation is cloud native tools. I'll walk you through the concepts of cloud versus cloud native, why everyone wants to be cloud native, the changes to application architecture, aka why is there a need for new tools. We'll also have a closer look at the next generation application performance monitoring, security, and testing. Now, the terms are often confused, but cloud computing and cloud native are two entirely separate topics. Cloud computing, often referred to simply as the cloud, is the on-demand delivery of infrastructure, storage, databases, and all kinds of application services via the internet. Frequently, these are delivered by a cloud services platform like Amazon Web Services, Google Cloud, or Microsoft Azure with metered pricing, so you pay only for the resources you actually consume. Cloud native is the architecture for assembling all of the above cloud-based components in a way that's optimized for the cloud environment. Cloud native is also a destination, the ultimate goal line for enterprises looking to modernize their infrastructure and process, and even organizational culture, carefully choosing the cloud technologies that best fit their specific case. There are multiple benefits to becoming cloud native. I'm sure we've all heard the expression that every company is a technology or a software company by now. Today, leveraging the cloud is vital and an important strategy for all companies as they build on their digital transformation efforts. Thanks to the cloud, you get faster release paces as the applications are built in a way that allowed agility. You get superior consumer experiences as DoubleClick found in 2016 that 53% of mobile site visits are abandoned if a web page takes longer than 3 seconds to load. You also get the ease of management through the shared responsibility model, reduced cost through containerization and cloud standards. You get more reliable systems and the avoidance of vendor lock-in, as a containerized app is highly portable and abstracted as code and all of its dependencies together. The benefits become more apparent when we take a look at how our applications are changing. The modern IT world is moving away from monolithic applications in favor of microservices run in containers. The traditional scale-up environment that uses a fixed amount of controller resources and global visibility is replaced by a scale-out model. Controllers or nodes that have visibility to only the disks they own and are clustered together to create large, dynamic pools of resources. We now have easily automated, scalable, self-contained, and portable applications that allow for rapid software development. With all of that in mind, we need to address how our tools have to keep up with this increasingly complex landscape. A multitude, if not all, that were built for the static data center world can't provide us with maximum functionality in the cloud. The main challenges to address are the increased complexity of our systems. We have changes at every level, from infrastructure to application architecture. And we also have decreased visibility as we host our applications in the cloud, which in other words is infrastructure that's just simply not ours anymore. For a more detailed look into the cloud native tooling landscape, I'd recommend making your way to the Cloud Native Computing Foundation. It's a Linux Foundation project that was founded in 2015 to help advance container technology and align the tech industry around its evolution. At the time of delivering this presentation, 1,383 tools are certified by the CNCF as cloud native. I'm not going to go into more detail here for obvious reasons, but I've highlighted 3 areas of cloud computing that I believe are going to demonstrate the shift in the clearest way. Those are APM, security, and software testing, or QA. Quoting a 2018 Gartner report, most APM solutions were designed for a prior generation of applications that were monolithic and long-lived. These approaches are ill-suited to the dynamism, modularity, and scale of today's emerging microservices-based applications. Here we can clearly see the shift from traditional APM to a tool like Instana, for example, APM designed specifically for cloud-native environments. Next generation APM is characterized by distributed tracing, time series metrics, container monitoring, and insight into your microservice architecture. It puts special emphasis on AI, ML-powered automation, predictive analytics, and something that's characteristic to Instana, a detailed root cause analysis. All of the above are incredibly important as a modern application can consist of thousands of microservices and even more dependencies. In example, this is how 940 microservices look in a single service and dependency map generated by Instana's graphical user interface. Bearing in mind, that can be just one application. Now, moving on to cloud-native security, it's worth noting that this is an area of computing that's probably the most affected by the shift to the cloud. Looking back at the challenges next generation APM has to adapt to, security is affected from more angles. A cloud-native tool that addresses those issues from an end-to-end perspective is Prisma by Palo Alto Networks. If we look at the challenge of visibility, in traditional security, it was easy to monitor static environments. Now, cloud-native tools allow for insight into your entire hybrid/multi-cloud environment, all from one place. Next generation security tools are super fast to deploy with seldom issues as they run on an established platform and are consumed as SaaS. Time to value is cut down enormously, typically from 9 months down to hours, if not minutes. Maintenance is also handled by your cloud vendor. This is a big point as a big portion of customers start to look for cloud solutions after going through a maintenance cycle that makes them stop seeing value. Cloud-native security is OpEx-based, a subscription/consumption model, no lengthy contracts, easy to replace vendors, and payback typically seen within the first 6 to 9 months. And there's also no longer a need to update and patch your systems yourself, as your cloud vendor is obligated to do that through the shared responsibility model. And the challenge of capacity and elasticity is also resolved as a cloud-enabled elastic scaling takes care of seasonality and unexpected peaks. To summarize, a cloud-native security tool will have visibility into containers, microservices, and serverless, the ability to monitor and analyze transient and elastic workload data, a holistic view of the entire threat surface, and the option to be consumed in the form of software as a service. Now, finally, we arrive at the concept of next generation testing or quality assurance. Rather than comparing software here, I've chosen to show how migration to the cloud forces not just a shift in tooling, but an introduction of a new practice. Chaos engineering is characterized by running controlled experiments on your systems in order to prepare for future failures. Looking back at how much more complex, automated, and complicated our computers are becoming, the question isn't, is it going to break anymore, but rather how hard. Tammy from Gremlin, an end-to-end chaos engineering platform, describes the practice as a disciplined approach to identifying failures before they become outages. By proactively testing how a system responds under stress, you can identify and fix failures before they end up in the news. Traditional QA isn't a viable option anymore, simply because it only tests a small portion of your software stack. When we look at what a modern cloud-native application consists of now, including the underlying infrastructure, configuration, dependencies, or even people and processes involved, so much more can go wrong compared to a traditional IT environment. There's also a very important question every QA department is asking themselves. How do we test on something that's beyond our control? An example, the infrastructure leased to the customer by a cloud vendor. The introduction of chaos engineering tools should help to address some of these questions. Thank you very much for listening in. Hopefully this presentation has given you a little more insight into what cloud native tooling is and why we need it.